Okay, so it says, two objects of the same mass and volume, but different shape, are suspended from strings in a tank of water as shown. Consider the following student discussion. By the way, before I get to them, I'm going to draw a little free body diagram. Let's just say for this one. So on this one, we've got three forces on it. So we've got the force of tension up, we've got a buoyant force up, and we've got the force of gravity down. Now, how did I know to draw the force of gravity bigger than either of these? Because it's remaining at rest. So the sum of the forces must be zero. So the tension and buoyant force together must equal the force of gravity. Now let's get to their questions here. So student 1 says, both objects have the same volume, so both have the same buoyant force. Therefore, the tensions in the two strings must be the same. So, do you agree with student 1? Explain your reasoning. If student 1 is incorrect, modify the statement so it is correct. Student 1 is totally correct. Since they have the same mass, they will have the same force of gravity on them. And since they are the same volumes, they will have the same buoyant force. So remember that the buoyant force will be equal to the density of the fluid they're in, which is the same, times the volume of fluid displaced, that's the same for each of them because they're the same volume, times gravity, and they're on the same planet. So they have the same buoyant force, the same force of gravity, so they must have the same tension. So student 1 is completely correct. Student 2 says, no, that can't be true. The bottom of object A is deeper in the water, where the pressure is higher. Therefore, the buoyant force on object A must be greater and the tension in the string must be less. So student 2 is partially correct. This statement is true. The bottom of object A is deeper in the water and therefore the pressure is higher. So the pressure at this point here is greater than the pressure at that point there. But before you even start to get yourself turned around too much, just remember this. The buoyant force is solely a function of the weight of the water displaced. They're displacing the same volume of water, so they're displacing the same weight of water, so they must have the same buoyant force. One thing is there's less area here too. So this one is deeper, but it's less area than that. And it turns out no matter what crazy shape you made, those changing around of the effects would always cancel out because the only thing that matters is the volume of the fluid displaced. So student 3 says, I mostly agree with you, student 1. The buoyant force is the same on both objects. However, you forgot the force exerted down on top of the objects by the water above. The force is larger for object B because the top surface has greater area. So the tension in the string supporting B must be greater. So student 3 is saying like, oh look, there's more surface area to push down on B than A, and since the pressure is the same, that force has got to be greater. Well, that is true. So the force is larger on object B at the top of it. But before you let yourself get turned around, remember, the only thing that matters for the buoyant force ultimately is the volume of fluid displaced. And so they're displacing the same volume. You know it's got to be the same buoyant force. This one, remember, also has a bigger surface area down here, so you get more pressure there. But they'll always cancel each other out, no matter what. The only thing that matters is the weight and therefore volume of the fluid displaced.